We're now going to take a look at another way to take advantage of the concept of polymorphism. And in doing so, we're also going to introduce a new construct in Java, a concept called an interface. An interface is a type definition similar to the way a class is a type definition, except in an interface, you're only allowed to have public abstract methods or public static data. You're not allowed to have any kind of implementation details, so no instance variables and no method bodies. In figure 10.10 here, Payable Interface Hierarchy UML class diagram, we are showing you the next hierarchy that we're going to be looking at, and at the top of this hierarchy is an interface called Payable. And this interface, as we will soon see, will declare one abstract method that all of the classes in the hierarchy are going to have to implement. Now, we're going to have three different classes in this hierarchy, one called invoice, one called employee, and one called salaried employee. And the employee class, once again, will be abstract. And just for simplicity, we haven't included the entire employee hierarchy that we just did in the prior example. However, we certainly could have included the entire employee hierarchy. Now, you'll notice something different about this diagram, which is this dashed line pointing back to the interface Payable. This is an indication that the classes invoice and employee implement the interface Payable. So in Java, you actually have the ability on a per class basis to extend one other class and to implement as many different interfaces as you wish. So in our case, both invoice and employee will implement this interface Payable. However, they could also implement additional interfaces as well. And we'll show you the syntax for implementing an interface in a few moments in the next example. Now, separately, when you implement an interface, you get the same is-a relationship that you get when you extend a class. So I can say that an invoice is a payable object and an employee is a payable object as well. And then separately, because a salaried employee is an employee, a salaried employee is also a payable object. So what we're going to do in this next example is say that we have more than just employees that need to be paid. We also have to pay our invoices. So we're going to view all employees and all invoices as payable items. And then we're going to calculate the payment amount for each invoice and each employee along the way based on the type of the object. So if it's an invoice, we'll calculate it one way. If it's a salaried employee, we'll calculate it a different way. And notice I said salaried employee. That's because employee is still going to be an abstract class. The other thing that's interesting is that once a given class in the hierarchy implements an interface, such as the employee class here, all of its subclasses also implement that interface. So we're going to now take a look at an example that builds the hierarchy that you see here in figure 10.10.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.